right, my nutrition sports class, or my sports nutrition class, or my sports and nutrition class, or my eating and running class, or my jogging and sipping on Gatorade class. We're doing dietary proteins now. This is my first video for Chapter 5, Module 5. The dietary protein chapter is not really about you developing giant biceps and pectorals. It really is about making sure you eat enough protein, mostly to cover that which you lose every day, or through sports, or through other means. Consider yourself a sports car, especially if you're an athlete. You have a bigger engine, you have just more engine, which means you need to eat more protein to maintain the bigger, more engine, and you use it more. And that really is the key about dietary protein, to maintain what you have. And yes, if you do have growth needs, power athletes, bodybuilders, etc., then you're going to need even more protein. And that's really kind of the gist of the whole chapter. So, what do you need protein for? This is right out of our book. It's clear. New tissue building, yes. But for the vast majority of adults, it's what we call maintenance, maintaining the body that we have. Some of that is making enzymes. There are some uses of protein as hormones. Insulin and glucagon and epinephrine, those are all protein-based hormones. Estrogen and testosterone are fat-based hormones. Immune function. The human body makes billions of different kind of antibodies, and they all involve protein. Fluid balance, acid base. Yes, some protein in the blood is acidic, some protein in the blood is basic. The building blocks of proteins are called amino acids. Amino acids can be basic, they can be neutral, they can be acidic. And so all those kind of acidic and basic stuff that's protein based, that's sitting in your blood, actually acts as a giant counterweight. It's hard to change, for example, your blood pH. It's hard to change it because there's so many acid molecules and so many basic molecules. It's hard to move that pendulum, if you will. It moves. You can have alkalosis or acidosis of the blood, but it's hard to do it. Energy source. And we think of triathletes. If you were to do the Iron Woman, Iron Man event in Honolulu, that includes, I believe, like a 3-mile swim, followed up by a 100-mile bike ride, followed up by a full marathon. You're burning lots of stuff, carbohydrates and protein. But when you cross the finish line, you're also burning protein. I'm sorry, carbohydrates and fat. But when you cross the finish line, you're also burning protein. It's all hands on deck. Should you use dietary protein for an energy source? Ideally, not. But athletes, you will if you have to. And then, cellular signaling, transport. There's transporters that bring things into cells. There's transporters in the blood that carry things through the body. Those are all protein based. If you really think about it, DNA is an instruction set, a book on how to build a human. And what DNA tells you to build are proteins, right? You're thinking, well, Professor, that's not true because, I have fat in my body. I can make glucose in the body. That's right. You can do all those things using enzymes. And those enzymes are proteins. DNA is a blueprint for making the enzymes of the human. And then the enzymes make all the other kind of molecules, carbohydrates, fats, and whatever. Okay. Alrighty. What are proteins? Well, they're molecules made up of things called amino acids. Amino acids are kind of like, the best example you can give of a protein is a pearl necklace, like a really long pearl necklace, or an Italian charm bracelet that's really, really long. And instead of having, like one kind of pearl, like a gray pearl or a black pearl or a white pearl, imagine you get 20 different pearl colors. Or if it's an Italian charm bracelet, 20 different charm varieties. And so that means every time you come to a new pearl or a new charm, you get 1 to 20 to choose from. And that can be a 50 charm pearl long thing. In this instance, it's called an amino acid is the building block. Or it could be 1,000 long. So they are complex molecules made up of building blocks. They're called amino acids. There's 20 of them. They look very different. Do I have a picture of them? I do. So these are all the amino acids that the body uses to make proteins. and the body strings these together, if you will, like individual pearls in a necklace. Some of these are acidic, some of these like fat, some of these like water, some of these are basic. Some of these have sulfur, some of these have lots of nitrogen in them. Some have less nitrogen. They're very complex molecules. They're all very different. And what this really gives you as a person is a lot of variety. So amino acids are the building block. Glucose, fructose, and galactose technically were the building block of all your carbohydrates. Linolenic and linoleic, so omega-3 and omega-6 were kind of the building blocks of the essential triglycerides that you needed to eat. Amino acids are the building blocks of the proteins. And there's 20 of them. 11 the body can pretty much make, right? We can make them. 9 we can't. So we call them essential. If you look on a plate of food and you say, okay, there's some tofu here and there's some salmon here. And inside the tofu and inside the salmon, there are protein molecules. And inside those protein molecules are the building blocks of the proteins called amino acids. The question really is, on your plate, do you have a lot of the 9? Because if you got a lot of the 11, we can make those anyways. For us, it's the 9 amino acids. Those are the essential. You have to eat them. Now, when you're an infant, you actually you have to make more than 9. So sometimes things that you normally can make as an adult, you can't make as an infant. We call those conditionally essential. It's not a very common term to use anymore, mostly because it really applies to usually just infants. And adults are pretty much, we need 9, we can make 11. Of course, if you eat the 11 that you can make, you will absolutely use them. If you eat cholesterol, you will use it, but you don't need to eat cholesterol. So the goal is the 9. 9 are essential, there they are, and 11 are non-essential. And you don't need to know the tyrosine or cysteine. And again, these are very different looking molecules. By the way, these are not to size. Some of these are much bigger than the other ones. I believe glutamine, if it's up here anywhere, is the most basic amino acid. And then where's my histidine? Histidine is a pretty complex looking amino acid. Okay, we're going to end there and we'll pick up here.